Hello class, this is Dr. Kanal. This is the solution of exam midterm 2. Okay, let me write down here solution. So, and this is the version A. We had like 3 version A, B and C. This is the version A of the question, which we have as usual. Have 5 short question, 1, 2, 3, 4 and 5, total worth of 20. And then we have a long question here, 26, 7. 6 is from chapter 6, 7 is from chapter 7, 8 is from chapter 8, and 9 is from chapter 9. So, 9 is from chapter 9. So, we have this second exam, which is from chapter 6 through 9. In our first exam, we had from 1 through 5. These are short question I don't want to do, or actually I do, but very briefly. I don't want to explain too much. This one, the Edison figure represents a multi-flash photograph of a ball being shot straight up. The spring initially compressed and then released. Well, in this one, the speed of the ball was greatest at y0. Well, or statements, you can have multiple answers. So, excuse me. The speed of the ball was greatest at y0. Of course, it will be 0 here, and speeds up, becomes maximum, and then goes up, gravity pulls down and becomes 0. So here is the speed maximum. Of course, this is right, and the speed of the ball was increasing from y bottom to y0. That is also correct. The kinetic energy of the ball was greatest at y0. Of course, when the speed is maximum, if these two are the same question anyway. So kinetic, the velocity, speed 0, speed maximum means the kinetic energy maximum, which is half mv square. All right, so this is also right. D, the kinetic energy of the ball was greatest at y bottom. Of course, at y bottom the velocity is 0, so this is not right. And the potential energy of the ball was greatest at y0. Well, y0 is not the maximum height. The potential energy has to do with the height, so these two are not correct. This one, what is the magnitude of F of the upward force? You have to find out this one, which is, of course, the tension will be same. So this and this, if it is F, this will also be F, and that will balance the weight, which is mass times gravity. So basically, F plus F minus mg equals to 0, which means this will be one half of the weight, which is mass times gravity. This is just like the problem which we had in the class. One of the problem that has on the bathroom scale, if your weight is, let's say, 50 kilograms, let's say like 500 Newton, and your mass is 50 kilograms. So if you have 500 Newton, so the force exerted on one leg on your bathroom scale, if it is like it shows, let's say 500 Newton, then on one side it will be like 250, half of it, so 250. So this is the kind of similar question. And this one, which is if you are leaving, what it says, if you're as you're leaving the building, the door opens outward if the hinges on the door are on your right. So you are going out, your hinge is on your right, so hinge is on your right. Okay, so so you're going outward, your hinge is here, you're going outward, right? So of course your thumb will give you, this is a right hand rule, so thumb goes down. So your hinge is here, and if you go outward, so it goes down, right? Hinge is on your right, so this is the right hand rule. Number 4, circle true and false. In an elastic collision, momentum and kinetic energy of the system, of course, yes, elastic collision means both momentum and kinetic energy are conserved. The work done by conservative force, it depends on initial and when starting and ending position are the same, then of course it is 0. So that's true. When the force is applied in a radial direction, so if a force is applied in a radial direction, the magnitude of the torque is like the torque your force has to be in this direction. If your L is on this side, your force has to be this, so in order to have maximum torque. But if your force is in the radial direction, well, in this direction, of course, if the force is in the radial direction, so this will be 0 because it has to be 90 degrees. So in other words, FL sine of theta, this theta is 0, that gives you 0. So the torque is maximum. Oh no, of course it's not maximum, so it is false. The two rotating system down here, identical movable thing, different distances. So this is like far, and these are shorter distance. If you release from rest on a slip, which goes slower means that has the higher moment of inertia, right? That goes slower. So this one has higher, that goes slower. So of course this one, which one on the left, block on the left goes slower. All right, this will reach faster to the ground. Okay, so these were the short questions. Now the long one, of course your time is about 1 hour, so so it's a class time, the total time. Let's do this one, which is 1 end of a horizontal spring with a force constant. Okay, this is a long question. So 1 end of a horizontal spring with a force constant 72. So force constant is K. K is, let me start with A. K equals to 72 Newton per meter. Attached to a vertical post, 2 kilogram ice block, which is mass equals to 2 kilogram. Ice block of frictionless ice attaches to other end and rest on the floor. Okay, so this is your post, this is your vertical post, and you have horizontal spring. So horizontal spring, and this is your ice block. Okay, so this is your ice block. Mass equals to 2 kilogram. Here K equals to this. Okay, the spring is initially neither stretched or compressed. Okay, constant horizontal force of 49 Newton. So you have a constant horizontal force of 49 Newton. F equals to 49 Newton is then applied to the block in the direction away from the post. Of course, away from the post. This is your post, right? And away from the post. What is the speed of the block when the spring is stretched to 0.3? So if the string is stretched to 0.3, let's say the block when the spring is stretched to 0.3, so from here to here, let's say 0.3 meter. So if it is at 0.3 meter, what is the speed? Find the speed. V equals to what? That's your question. Okay, so here this is the total work done will be your force times distance, which is 0.3. so that work will be done, and that will be used in two things. First, the energy stored in the spring, right here, with half kx square, and then the remaining the kinetic energy of this guy. So how we tackle this problem is, well, you can say the work done by force will be elastic potential energy plus the kinetic energy, right, plus K. So, or what you can do is WF is nothing but F times X. Let's say this is your X. All right, so F times X minus, when it comes left, it will be minus anyway, the force applied, and then the spring will pull on this side. So the spring does the work, so the force will do against the spring. So in other words, you have to subtract minus of, or you can say this comes left, becomes minus of kx square. This is the work done against the spring. which will be equal to, the remaining will be equal to the kinetic energy, which is 1/2 mv square. So just plug all those things. What you get is F is what, 49 times x is 0.3 minus 1/2, k is 72 times 0.3 square, which equals to 1/2. Your mass is 2 v square. That's what we need to find out. So all you have to do is just simplify this equation. So this 2 and 2 cancel, so it's easy. All you do is whatever is here, take the square root. Okay, so let me use my calculator again. In your test you are not allowed to use calculator anyway. Okay, yeah, sorry, you are not allowed to use phone anyway. So here 49 times 0.3 minus 72 divided by 2, which is 36. Anyway, I'll do it 72 divided by 2 and then times 0.3 square. That will give you 11.46. so v square equals to 11.46. v equals to, take the square root of your answer, and v equals to 3.39 meter per second. Okay, so this is your part A. What is part B? Part B is at that instant, what are the magnitude and direction of the acceleration of the block? Okay, so at this point what happens, you have to find the total. So the Newton's second law says net force equals to mass times acceleration. That's the bottom line. So here are two forces. One force will go this way, which is 49 F, and the net force is mine, because once it's here, the spring is pulling on this side. So the spring force is kx, which is pulling on this side. So net force will be this minus kx. So this guy will be F minus kx. This will be ma. So your F is 49 minus k is 72 times x is at that instant means 0.3, which equals to mass is 2 times a is what we need to find out. Again, I'm not writing units because again we are much familiar with the units. So what is the acceleration again? So all you do is just do this 49 minus 72 times 0.3, that gives me 27 point something, and then you divide, this 2 goes left, divide by 2, and this will be 13.7. so your acceleration is 13.7 meter per second square. All units are in SI system, so I'm not much worried writing here. So bottom line will be this. Okay, so and third one is, what is the maximum displacement of the block with the same constant, this force? So when you keep on pushing it, what would be the maximum horizontal maximum displacement from here? So this is basically the same thing. At maximum displacement, your velocity will be 0 at the end, right? At the end, maximum displacement, your velocity will be 0. So all you have to do is make the same thing, find x. All right, so see, at maximum displacement I can write here F times x max. Let me write down x max minus half k x max square will be 0, right? Because velocity is 0. Okay, so when you simplify this, one is x max equals to 0, but you discard that, right? So your F equals to what it will be is when you take it on the right, it will be half kx, right? So x max equals to 0, discard, right? Discard. The other one is you get x, so your x equals to 2 times f. Your f will be 49, and then divided by k. K is 72, so your x will be 2 times 49 divided by 72, so that will give you 1.36. okay, so 1.36 meter. By the way, you can do this problem another way also. Here, if you look at this, when you push it, what happens? Your velocity keeps on increasing and becomes maximum. So it's like a simple harmonic motion, which we discuss later. It's not in this chapter, but basically what happens is this block, when the spring force and this force becomes equal, at that point your acceleration will be 0, right? So meaning your velocity keeps on increasing, becomes maximum, your acceleration becomes 0, and then velocity keeps decreasing, becomes 0. So what you can do basically is, from this point onward, only half, your f equals to kx, right? So just you do this, find x, and whatever is the x, this is like x amplitude, we call it like the radius, right? So what you can do here is find xa. So you can do this, f equals to kx. I write here xa something, so your f will be 49 equals to k is 72 times xa, and then you get xa equals to 49 by 72, whatever it is, but your x max is from here to all the way there, so it will be double of this. So in other words, you can do this way, and whatever you get here, the answer 49 divided by 72, okay, 49 divided by 72.68, so this is 0.68. so all you do is x max equals to 2 times xa. You can do it this way also. So this should give you the same number, okay, 1 point whatever it is, 1.36. if you multiply this by 2, this will be this meter. So you can do this way also and this way also. Okay, so let me move to the next one. All right, this one is 2 blocks. Let me go it little little zoom out, so hope it is readable. Okay, 2 blocks with 2 different masses. 2 different masses are attached to each other. The light rope passing frictionless pulley suspended from a ceiling. The mass m1 on the floor, so this is on the floor, and heavier mass m2 is at 1.5 meter from the ground. So I write here 1.5 meter from the ground. So this is at 1.5 meter from the ground. The masses are released from rest, and the mass m2 starts, of course, it goes down, it goes up. The mass m2 hits the ground with the velocity of this. Okay, there's the trick. This guy hits the ground with the velocity here. All right, so this velocity equals to 4 meter per second. The total mass of the blocks 25. So here given clue is m1 plus m2 equals to 25. Total mass is this, and the velocity is this, the height is this. That's the whole information. Actually, this was kind of similar problem that I gave you guys in exam 1, the first midterm, but this one is using I should have written here, use the energy method. Okay, so anyway, I told you in the exam room that you have to apply the energy method. You cannot use the chapter 2 way, or the chapter 4 actually. So you can do that. Energy method is, first you get the total energy. Your formula is what? The formula is K1 plus U1 plus W other. You don't need, because there is no any extra force, right? W other like friction or any applied force externally, nothing. So I don't want to write here W other. So K1 plus U1 equals to K2 plus U2. That's the whole formula, right? So initially find out the K1. K1 of this initially is 0. There are two of them. So this one has 0 plus another, this also has 0, right? Both kinetic energy is 0. Plus U1 of this is 0. U1 of this is mgh. So plus m2 times gravity times height, right? Okay, equals to K2. Now when it's here, of course this will be up, right? So K2, when it's here, your K2 will be the velocity of this is this, so 1/2 of, now you have velocity of this and velocity of this. So m1, kinetic energy 2 of m1 will be m1 of v square, but this way and this way will be same, so I can just write down m1 plus m2 and then straight over v square, because those two velocity are same, one going up, another going down. You may have thought like one will be negative with respect to the other, but doesn't matter, the kinetic energy will be like positive either way. So, and then it is assumed as a single system, so it's like you make it straight and then it moves with the same velocity, so it doesn't matter. Okay, so 1/2 m1 plus m2, the same system, v square, this will be this, plus the potential energy now will be, this will be on top, so this is m1gh, right? Plus this will be 0 because this is at the bottom. So you have 2 kinetic energy initially and 2 kinetic energy finally, and 2 potential energy initial and 2 potential energy final. So all you have to do is just collect all the kinetic energy and all the potential energy, initial stage and the final stage. All right, so you are done now. Okay, so what you can do here is, since you have m2, m1, they are not given, but you are given m1 plus m2 is 25. So what it gives you is, you can convert m2 to m1 or m1 to m2, either way. So you can do, like, let's say m2 equals to 25 minus m1. So wherever it's m2, just use this, all right, to simplify it. Okay, so in terms of m2, this gravity is 9.8 times your height is 1.5, and then m2 is, I write here 25 minus m1, I can do that, equals, you have 1/2 m1 plus m2 whole is given 25. I know some of you, what you do is you just leave it like this, m1 v square plus 1/2 m2 v square, and in place of m2 just use this. So you can do that way also. Okay, so velocity is 4 square plus m1. What is your m1? Okay, you don't know m1, you are converting everything in m1. Gravity is 9.8 times your height is 1.5. That's it. Okay, so all you do is just simplify this. So let me simplify this one. Let me simplify this one, which is 9.8 times 1.5. 9.8 times 1.5. I'll do that for m1. So equals, I'll do 14 point minus 14.7 m1, right? Now I have this left, times 25, this will be 367.5. So 367.5 minus, so I hope you got it right, this times 25 will give you this, and this times m1 will give me this. Okay, let me simplify and then we'll bring it later. So 25 times 4 square divided by 2, which is 25 times 4 square divided by 2, which is 200. Of course, because 4 and then another 4 will be 2. 4 times 2 is 8, and 25 times 8 will give you 200. Okay, plus 9.8 times 1.5, which was same thing. So this will be same thing, 14.7 m1, because minus comes on the right, it gets added, so there's nothing wrong with this. Or so this goes on the right, which gets added. So let me do here, let me do here 14.7 plus 14.7, which is times 2. I can do it straight away, 29.4. So this will give me 29.4 of m1, and then what happened, this goes on the left, which is 367.5 minus 200 will give you 167.5. so your m1 will be 167.5 divided by 167.5 divided by what, 29.4. That'll give me 5.7 kilogram. So if m1 is 5.7 kilogram, m2 will be 25 minus, so m2 equals to 25 minus 5.7. this will give me 19.3 kilogram. Okay, so basically here the idea is, all you have to do is k1 plus u1 equals to k2 plus u2. You get k1 initially when they are not moving, when they are at their initial position, your k1 is 0 for this one as well as this one. And the potential energy also, this one is 0 because it's on the ground, but this one is at a certain height. So on the left side your energy will be only m2 gravity times h, only this is the total energy. And the final, it will be, since the energy is conserved, so the final will be, since they are moving, just before it hits the ground you have velocity v, so you have like both of them are moving, so your velocity will be both of them, half mv square. But the potential energy, this is already ground, so this is 0, this one is up, so this one has the potential energy of m1gh, and remaining is just the simplification. Okay, so here the other one. Excuse me. Find the velocity of the block. This is an interesting one. Find the velocity of the blocks on their halfway when they just pass each other. So now if I go to this question, let me use red ink. Okay, so if I use a red ink, so on their halfway means somewhere here, somewhere here, so this goes here, and this, let me draw it here. So on their halfway means this also will be here. I'm running out of ink, the red pen. So this is something like this. All right, it was here initially, this was on the ground initially. So when they're on the halfway, if it's 1.5, then this will be half of 1.5, so which is 0.75. half of 1.5 will be 0.75 meter. All right, so in this case it's the same formula. The difference, the first thing, it doesn't change because initially it is same condition, but the second stage is they are halfway. So let me repeat the same thing. Initially it is 0 plus 0 plus, of course this one is 0 plus this one is m2 gravity h. So this is same thing, but the final is when they are on a halfway, they both have the kinetic energy, which is 1/2 of m1 plus m2 v. I this one is say v1. Okay, v1 square, which is this one halfway, v1 square, same thing, plus here's the trick, m1, this one has what, potential energy m1g, not h but half of h, so this will be m1g h by 2, and this one will also not be 0 because this is not at the ground, this is also halfway, so this also has the same potential energy, plus m2 also g h by 2. So that's the only difference. So now all you do is you have m1 and m2, you just simplify it. It's straightforward. So you need to get the velocity now, right? So all you have to do is m2 is, what is it, 19.3 times 9.8 times your h is 1.5. This will be equals to 1 excuse me 25 times your v1 square plus m1 will be 5.7 times 9.8 times h divided by 2 is 0.75, because h is like half of it, plus I'm going to write it here, plus excuse me, what is your m2? M2 is 19.3 times 9.8 times this one also 0.75, so this one is 0.75. So all you do is just simplify this. So let me simplify this. You have only here, so this I'll do it straight. Okay, so this one is 19.3 times 9.8 times 1.5, and then now this one minus, this goes on the left, becomes minus what, 5.7 times 9.8 times 0.75, and then I could have done what, you know what, g h over 2 and then m1 plus m2. m1 plus m2 is 25 anyway, so that could have made me a lot easier rather than doing this. All right, it's a little tedious way. So what you can do here is m1 plus m2 times gravity times s2. Okay, it adds over 2. So anyway, it's a little lazy way, but that's okay. So this goes on the left, it will be another minus, right, which is 19.3 times 9.8 and then times 0.75 times 0.75. So this will give me 99.96 something, and then all you do is multiply by 2 and then divide by 25, because, and then this times 2 and then divide by 25. So this means 7.99, or basically 8 meter. What is it? It's no, something wrong here. Oh, and then you have to take the square root. All right, so and then take the square root, because remember the velocity halfway cannot be more than 4 meters per second. Okay, so taking the square root of answer 2.83 something. Okay, so your velocity 1 will be 2.8 something meter per second. All right, so and the idea here is, well, you could have done this one again. This one you could have done m1 plus m2 and then gravity times 0.75. Okay, straight away. m1 plus m2 is 25. You don't need to do all those. All right, so this was about this problem. Next one, what is this? Oh, this is another easy one. By the way, I keep on mixing. I always mix a little easier and harder question, even though it has same worth. It's fair for me, because at least you I'm just trying to figure out whether you could do all of them or not. Okay, so this looks quite easy question, because you're standing on a large sheet of frictionless ice. In order to get off the ice, you throw the rock. So you are here, you throw the rock, right? So when you throw the rock with the velocity 10 meters per second, 10 meters per second, your mass is 65, your mass is 65. Let's say you are m1 and the rock is m2. So rock is 2.5 kilogram. Okay, you are 65 kilogram, rock is 65. So what is your velocity when you throw the rock horizontally? Okay, that's pretty much, this is you, this is the rock. So when the rock goes this with 10 meters per second horizontally, so initially both are 0, so the formula will be m1 initial momentum will be what? This is a conservation of momentum problem. So m1 v1 initial plus m2 v2 initial equals to m1 v1 final plus m2 v2 final, or I think guys wrote like ma va, 2 is b or something. Either way, so this one is 0 because initially nothing is moving. This one is also 0, equals to m1 v1 final is m1 v1 final. That's what you need to find out. So 65 times v1 final you need to find out, plus m2 is 2.5 times v2 final is, you have 10 meter per second, right? Again, I'm not writing units. So v1 final will be, your velocity will be minus what is it, 25 by 65 minus 2.5 times 10 will be 25, and then 65 goes down. So this will be 25 divided by 65. So that is minus, what is it, 25. I can just do 25 divided by 65 and then put minus sign. So this will be 0.385, so 0.38 something, 0.385 meter per second. I could use only two significant figure. Okay. So now here, what will be your velocity when you throw the rock at 10 meter per second but at an angle of 32 above the horizontal? So here's the thing. So you are here, you are throwing this at an angle 10 degree. Your velocity is same, this is 2, right? v2 final will be same thing, 10 meter per second, but it is at an angle of 10 degree with the horizontal, not like this straight horizontal. Okay, so this one, so how will you tackle this problem is the following. Same formula. Initially you have 0, this also is 0. The final is, this one will be cosine. Of course you have to do it x now, right? So your formula will be m1 v1 initial along x direction plus m2 v2 initial along x direction equals to m1 v1 final along x direction plus m2 v2 final along x direction, and then again y also, you have both x and y. But in this particular problem, since you are throwing it and you are on a frictionless ice surface, so there is no way you can go down along the y direction. So for you have only x, so all you have to do is only the x thing. So this one will be m1 is what is your m1? M1 was 65. You need v1 final along x, okay, plus m2. What's your m2? 2.5 times v2 final is 10, but along x will be 10 times, this will be cosine of 10 degree, right? So you have to have take the x component. If it were sine, if it were going down, in one of the problem of billiard ball or something that I did in the class, has like the ball after a strike, it goes here and then there, right? And so in that case you have to do it both x and y, but here it's much easier problem. So all you do is just simplify this. Of course what you know is this answer must be smaller. Oh, by the way, it was negative, so since negative it goes back, that will be the direction. All right, so anyway, in this case your answer must be smaller than this. All right, that's for sure, because the component will be smaller than 10 meter. So when it's small, so the reaction will also be small. Okay, so you need to get this. So all you have to do is your v1 final along x will be, this will be minus, okay, 25 cosine 10, this will be 25, but you have to multiply by cosine 10. So 25 times cosine of 10 degree will be 24.6. So this thing will be 24.62, and then divided by, you have 65, so then this guy divided by 65 will give me 0.378, 0 point, so this will be 0.378 something. Okay, oops, my bad. So this is actually 32 degree. I thought like 10 degree. It's my bad. So basically it is 32 degree. Hold on. So let me change it to 32. I want to use a pen. Where is it? Okay, I just want to write it with this pen. So basically this is not 10, but this is 32 degree. So this will give me 32 degree, and then this will not give this. So let me change it a little bit. I don't want to erase, because if it was 10 degree here, this answer would have been this. Okay, so since it was 32, so I'm gonna change. I'm gonna write it 25 times cosine of 32, cosine of 32 there, and then divide by 65, divided by 65. So this will give 0.326. So in that case it will be 0.326, okay, meter per second. All right, so this is for 10 degree on this side, but this one for 32 degree. All right, so they are two different things. Okay, so anyway, you got the idea, right, how to solve the problem. So this is of course less than this one. All right, okay, so this total question is about like 1 hour something, your class time 1 hour 25 minutes or something, sorry, 1 hour 15 minutes. Let's finish this one. An electric fan is turned on from rest with constant acceleration t. So electric fan, right? Fan is turned on. It has angular speed of 200 revolution per second. At a certain time t, it has 200 revolution per second. Okay, let me start with here. It's a rotational thing, so it's very hard for me to overwrite on the same circle. So let's say at this is t equal to 0, and after a certain time t, it has the omega 1, I should say. Your omega 0 equals to 0. Omega 1 will be 200 revolution per second, and then this is at t, and then another additional 3 minutes. So another 3 minute you have another omega here, which is omega 2 equals to what is it, 500. So this is super easy question. You can, since the acceleration is constant, so constant angular acceleration means your alpha is constant, right? So those terms, 3 terms are given it, w, omega 1, omega 2, and then time. So here you can use this information to get alpha. All right, so only this is enough to get an alpha. Omega 1 equals to 200. By the way, you can change into radian per second, which is just multiply by 2 pi, right? Because one revolution has 2 pi angle, 2 pi radian. So you can either you can convert into radian per second and then solve it, or since this one it cancels anyway, it looks like okay, let me do it for you then. You have 500 revolution per second, right? And your time is 3 minutes, which is 3 times 60 will be 180 second. So the formula will be what? W2 omega 2 equals to omega 1 plus alpha t, right? So if you have this formula, or alpha equals to omega 2 minus omega, change in, so you can write down alpha equals to change in velocity per unit time. So omega 2 is 500 minus omega 1 is, what is it, 200 divided by 180, and this will give what is it, 300 by 180. Okay, so 300 divided by 180, so there will be 1.67. So this one will be revolution per second square. The reason here is omega is revolution per second, this is also revolution per second. So I'm not much, you don't really need to change it to radian per second, because this gets subtracted, it remains the revolution per second, and there's one more second, so that gives you second square. The change will be only second to second square, revolution remains same. So you can do it this way, or again you can, or you can multiply this 200 times pi, and this will give you radian per second. All right, so I'm not worried whatever way you go. All right, so now excuse me, so now the next question, find the time, find this time. So once you have alpha, now you start with this and this same formula, which is you're now omega 2 is omega 1 alpha t, but omega 1 equals to omega 0 plus alpha t. All right, by the way, this t is this t. All right, this t is 3 minutes, but this t is this t. So I should write here, not to get confused, this is t2. All right, t2, so t2 equals to 3 minutes, t2 equals to 3 minutes, just to not to confuse you. So the first time is t, so it sounds a little different, first time. Okay, all right, t equals to omega 1 minus omega 0, sorry, what do you need? Okay, t, omega minus omega 0 divided by alpha, which is omega is what, this is omega is 200 now, right? Actually omega 1 is 200, omega 0 is 0, divided by alpha is 1.67. So this will give you, and this do reciprocal answer, right? 1 over x, 1 over this times 200. So reciprocal of the answer and then multiply by 200. This will give you 120 second. In fact, it is 2 minutes. All right, which is 2 minutes. All right, so this is one of the easy questions. So that's it.